to you about how to do titration calculations. Now, I need you to follow these 4 steps every time you work it. Now, some of you are going to figure out some other ways to do it. I need to see these 4 steps in order for you to get credit. You've got to follow these. So if you are not following these 4 steps, instead doing a shortcut, unfortunately, I'm not going to be giving you credit for it, and nor will your sub. So you need to make sure that you're following these 4 steps. Here's what I want to tell you. If you memorize and follow these 4 steps, it's going to get you the right answer every time on these titration calculations, okay? The first thing you're going to do is write a balanced equation. Why? Because we are neutralizing an acid with a base. So because of that, we need to see the chemical formula, the equation. Calculate moles of the known solution. How do you know which one's known? It's the one that has a volume and a molarity. We have enough information there to calculate moles. Then we're going to use our equation and we're going to do a mole to mole ratio to figure out the moles of our unknown. Then we'll have everything we need to calculate the molarity of our unknown. Because you remember titrations, the whole purpose of them is to calculate the unknown molarity of a solution. So therefore our calculations ultimately need to get us to the molarity of the unknown. Okay, here's an example problem. If it takes 54 mils of 0.10 molar solution of NaOH to neutralize 125 mils of an HCl solution, what is the concentration of the HCl? So you can see here, the HCl is the unknown because we're looking for its concentration. The NaOH is the known because we are given the volume and the molarity. Step 1, write the balanced equation. So we add NaOH plus HCl. We always get water and salt. Na plus, Cl minus. So that is a 1-to-1 ratio there. Don't forget your little states of matter. Aqueous, aqueous, liquid, aqueous. Make sure your reaction's balanced. We do have everything is balanced right now. Yep, we're good. Okay, check. Yay. Step 2, calculate moles of known. So we know that we have 54 mils of this and it's 0.1 molar solution. So molarity equals moles over liter. That's what we're going to use here. Our molarity is 0.10 equals, we're trying to find the moles. Okay, so we need to put our volume of NaOH on the bottom here. Ooh, look, it's in milliliters. We've got to make sure we convert that to liters. So it's 0.054 liters. Multiply that by 0.054 times 0.1, and we get 0.0054 moles of NaOH. So now we've done moles of known. Let's look at our mole to mole ratio. That's looking at our equation. When you look at our equation for every 1 mole of this, do you see how we also have 1 mole of this? There's that 1-to-1 mole ratio. So if we have 0.0054 moles of NaOH, don't you agree? We'd also have 0.0054 moles of HCl. So in order to show me that you're actually doing this next step, you got to write something out. So the first thing, you could just write out 0.0054 moles of NaOH equals 0.0054 moles of HCl. If you look there, that's telling me that you've looked at your reaction and you're thinking about the mole to mole ratio. Now, if you want to set up the dimensional analysis, you definitely could. That would be like this. 54 moles of NaOH. We set this up. Moles of NaOH go on the bottom. We're trying to get to moles of our unknown, HCl. And if you look, there's our coefficients, 1-to-1. You can definitely set that up if you want. I'm not going to require you to do this part because this is using your brain as well. So if you can look at this and know they're going to have to be the same since it's a 1-to-1 mole ratio, I'm definitely okay with that. But if you need to set up the dimensional analysis, that's okay too. So now that we have our moles of our unknown, we can now calculate the molarity of the unknown because we were given a volume of the unknown and we just calculated our moles of the unknown. Moles per liter. So 0.0054 moles divided by, our volume's in milliliters. Don't forget to convert that to liters. We got to move the decimal place over 3. There we go. 0.0054 divided by 0.125. I'm going to go and grab my calculator for this. 0.0054 divided by 0.125. And I get 0.043. Look at sig figs here. 2, 2, and 3. So we need to say 2 sig figs in our final answer. And that is the concentration, so it does need a unit. And now I'm done with step 4. Okay, I'm going to go ahead and do one more example with you. We're going to follow through the exact same steps, but it's not going to be so easy because our mole-to-mole ratio won't end up being a 1-to-1. This is why we've got to watch that mole-to-mole ratio. I would say that's probably the most common mistake that students make when working these out is they do not think about the mole-to-mole ratio when it's not a 1-to-1 example. So that gives you a sneak peek for what's coming here. Let's read this problem. What is the molar concentration of 50.0 ml solution of NaOH that is titrated to an endpoint with 15.0 mL of a 0.00300 molar solution of H2SO4? So here's our unknown. NaOH is our known. Let's write out our formula. Our equation, because that's step 1. NaOH plus H2SO4 yields salt and water. SO4 2 minus Na plus. Make sure you're balancing those charges. Na2 SO4 plus water. Now we have to balance our reaction. So we have 2 sodiums here and just 1 here. So we definitely need a 2 here. That gives us 2 oxygen and 4 hydrogen, therefore we need a 2 right there. So can you already see how this problem's different? We have 1 of these for every 2 of these. So that's going to affect our mole-to-mole ratio step. Cool. Okay, let's do our right balanced equation. Check. Let's calculate the moles of the known. We have 50 mils that is our unknown in this example, isn't it? NaOH, I said that wrong earlier. NaOH is our unknown of this example, and H2SO4 is our known. And we definitely have 15.0 mils of a 0.00300 molar solution. So 0.00300 molar equals moles over, this is in milliliters again, we got to move that decimal place, 0.015 liters, and there are 3 sig figs there. So in order to solve for moles, we got to multiply. So that's going to be 0.003 times 0.015, and I get 4.50 times 10 to the -5 moles of H2SO4. Okay, now let's look back at our problem here. For every 1 of these, we have 2 of these. So if we had 2 moles of this, we'd have 4 moles of this. If we had 12 moles of this, we'd have 24 moles of this. Do you see what we have to do? We've got to multiply this number by 2. So you can do this one of 2 things. We could say 4.50 times 10 to the -5 times 2 equals 9.00 times 10 to the -5 molar, and that is our sodium hydroxide concentration. Or you can set up the dimensional analysis. So I'm okay with you either doing this or setting up the dimensional analysis. And it's always good to, oops, this is not our molar. This is our number of moles. Moles of NaOH. It's always good to have your units in your work. So that's the first thing. You could also set it up this way. 4.50 times 10 to the negative fifth moles of NaOH for every here's what I did. We'll fix that. Moles of H2SO4. Okay, yeah, there we go, because this is there's our unknown there. For every 4.5 times 10 to the negative fifth moles of H2SO4, we have 1 mole of H2SO4 for every 2 moles of NaOH. So you see, even when we set up our dimensional analysis, we're still multiplying by 2, and that's how we get our 9. So I'm okay with you setting this up. I'm okay with you just doing this, as long as you're showing that mole to mole ratio. Okay, so now we've calculated our moles of known, and we've done our mole to mole ratio. Okay. Last thing we have to do is calculate the molarity of our unknown. Our unknown is NaOH, our known is H2SO4. So let's calculate our molarity of this. Now we have a moles, and we have our liter over here, this is 50. So to calculate our molarity, it's going to be that 9 times 10 to negative fifth moles, and this does have 2 sig figs, divided by, right here, 0.0500 liters. Okay, let's go ahead and do that. Divided by 0.05, and I get 0.0018. And let's look at sig figs, 33380 molar. There you have it. Those are how to calculate titrations. Please do not forget these 4 steps, and this is how I want to see your work done.